Good evening, everybody. Hello, good evening.
Good evening.
Welcome to yet another session. And I think we have to start because if you keep on delaying till everybody joins, then it will be like the norm and people will decide not to log on early. And those who will now be logging on early will now also begin to also slack behind, and then you will not make any progress. So I think with the approval of the director, we want to start. In the next 5 minutes, if there's somebody who wants clarification on some of the things that we discussed yesterday, is there anything somebody will want us to throw light on from yesterday's discussion? So I guess we can move on. All right, so we're just going to look at some basic procedures in microbiology where sometimes you can expect questions around, especially since this platform is the one where you have both the diploma, MLS, and then the MLSD all combined. Sometimes if you don't take care, you'll be talking about things that will not come immune to the benefit of the diplomates. So after you started like this, I think there are certain underlying principles that cut across. So they will be of more of interest to the diplomats at this time. And as we move up, then we will try to scale up also to make room for the MLS and the MLSD. So today's discussion purely will be like at the diploma level. Notwithstanding, it is also good that the MLS and MLSD also get this fundamental understanding so that to help to understand the things better as we move up. All right. So I want us to quickly look at some of the basic procedures in microbiology. And the simplest procedure is the wet mount, what we call wet mount, where a suspension of a sample or inoculum will be examined in a liquid form. So that's why we call it wet, because it's mostly in a liquid form. Now, all you do is just take a drop of the suspension of the specimen or the organism, place it on a slide, and then apply a cover slip, the exam. That's all that it is about a wet mount. And we do that all the time in microbiology. Now, depending on the medium that you are using to prepare your wet mount, we classify it as such. So for example, most of the time we use saline. So it becomes saline wet mount. Okay. Now, we can also use iodine, especially in parasitology. When you do a stool wet mount and you want to look at the morphology, or you want to identify the type of protozoa cyst, then you need an iodine to support. So once you're going to use an iodine as a medium of the preparation, We now call it iodine wet mount. Yesterday, you realized that we also talked about KOH, 20% KOH. Now, the KOH is also a wet mount because we're going to probably look at skin scraping and then adding KOH. So the whole preparation becomes a wet mount, okay? All right. So all that we are saying is that we use wet mount benefits to it. And you need to know this, especially at the diploma level. They can easily ask questions on some of these, that a wet mount can be used to, and then the answers will follow. All right. So if you use a wet mount, you can have an idea about the size of the organism and if the shape of the organism. If the organism is round, you can see it. If it is rod-like, you can also see it in the wet mount. Right. You can also see the arrangement, if they are in groups, if they are in clusters, if they are in chains, you still can see it in a wet mount. And more so if they are motile. See, especially in cases like if you do a wet mount of semen, all right, the sperm should be moving and you see their motility. All right, so it's also a wet mount, and you can see it. You can use it to determine the motility of the organism. So these are the major benefits, so to speak, of a wet mount. But it depends on the type of. If it's a saline wet mount, then all these things can go. But for example, if it's an iodine wet mount, for example, it can kill the bacteria, all right, or it can kill the organism. If you're dealing with, let's say, KOH, for example, it can also kill. So where you get all the benefits that we have cited above, will hold for saline wet mount. All right, but depending on how the questions are asked, you'll be able to always make out which one is correct and which one is not correct. Right. So there is another aspect of a wet mount which I've added here, which is the hanging drop test. Hanging drop test. It is important to know what is the use of hanging drop. All right, because you can, especially the diploma level, I'm saying that this lecture is purely for the diploma level. But that doesn't mean that the MLS and the MLSD2 are not of it. It is the foundation of the MLS and the MLSD place. But what I'm saying that a lot of today's discussion and the questions that will come up are tailored for the diploma level. Right. So what is hanging drop method? You remember we said that when you have a wet mount, it's just a preparation or a suspension of the specimen or the organism. Then you apply a cover slip. Now, if you have bacteria, bacteria is a microorganism, it's a small organism. And therefore, it can easily be influenced by what we call the Brownian motion. I'm sure all of us have an idea about what is Brownian motion from SSS level. If you have a liquid medium, okay, the molecules that make up the liquid medium are in constant motion. The molecules that make up a liquid medium are in constant motion. Now, if you put in a small particle, the movement of the molecules of the medium, which is in this case the liquid medium, will impact on the smaller particles to cause them to move. So the bombardment of the molecules of the liquid medium to cause the smaller molecules to move is what we call the Brownian motion. And I'm sure this is taught at SS level. Now, so if you prepare a wet mount, all right, and then you have bacteria in there, the bacteria will suffer from Brownian motion because the suspension, the medium, the molecules that make up the medium, which we have known to be constantly moving, will try to bombard the bacteria and to cause the bacteria to move. And therefore, it is technically inappropriate to do a wet mount and then use it to examine the motility of bacteria. Remember, you say you do motility for bigger organisms. If you are dealing with, let's say, the sperm cells, it's a bigger distance, so its motility is not influenced by Brownian motion. If you have amoeba, okay, you are looking out for amoeba is big enough, and therefore its motility is not influenced by Brownian motion. So you should be able to differentiate between motility of bigger organisms and then motility of bacteria and small organisms. Okay, they are saying that when you're dealing with bacteria, because they are smaller, they can easily be influenced by the bombardment of the molecules of the liquid medium. And therefore, if you are seeing bacteria moving, you cannot determine whether it is due to Brownian motion or due to the bacteria itself that is moving. And therefore, we don't use a wet mount to assess motility of bacteria. I know some people do that in certain labs where they only do a wet mount and they say that they're looking for bacterial motility. That is wrong. Please, that is a wrong approach. It's not acceptable bacteriologically. Now, so then comes in the concept of hanging drop. In hanging drop method, unfortunately, you may just have to follow me because I don't have slides on that. So just follow me. It is just a use of an ordinary slide. Okay, the ordinary microscope slide. In this particular microscope slide, the middle portion has what we call a depression. It's like the inside has been scooped. So it's a special microscope slide where the inside, the middle portion has been scooped. So there is a depression. And for that matter, that slide is called depression slide. Depression slide. So to do the test we call hanging drop, you need a depression slide. And then, of course, you need the ordinary cover slip. All right, so you need a depression slide and you need a cover slip. Now, you prepare your suspension. You know, for every wet mount, there should be a suspension. So you prepare your suspension and then you place a drop of the suspension on the cover slip. Okay, the depression slide is somewhere. But first you put a drop of your suspension that you have made on the middle of the cover slip. So try and follow me as much as possible. And then the edges of the cover slip, you apply Vaseline, something that can cause something to catch. So you apply Vaseline at the corners of the cover slip. Now, you are going to now place the depression slide on the cover slip. Remember, the portion that is scooped, the portion that has the depression, that portion is now going to, you are going to place that portion on the cover slip. And as you place it, because that portion has been scooped up, when you place it on the cover slip, the drop will not touch the slide. Because you are going to place the cover slip such that the depression portion is is placed on the cover slip. So you see that the cover slip has the drop, and then you are applying the what do you call it? You are applying the depression slide. So as you put the depression slide on it, the portion which is depressed will not touch the drop. And because you have applied Vaseline at the corners, the cover slip will attach itself to your slide. And then you turn it upside down. When you turn it upside down, the cover slip will come on top of the slide. It does, then you will see that the drop is hanging, the drop that you place on the cover slip will be hanging between the cover slip and the portion which has the depression. So that's all we call hanging drop. Now at this stage, if you place it under the microscope and examine, the movement that you see is a true movement of the organism, and it's not influenced by Brownian motion. Okay. So it may be difficult for you to comprehend, but that's all we know about hanging drop method. Now, so in effect, hanging drop method is a test for detecting motility of bacteria. Okay, so sometimes for purposes of examination, they can ask you which of the following organisms will test positive for hanging drop. All they want to tell you is to find out whether you know that hanging drop is a test for motility. And so if they ask you which of the following organisms will test positive for motility method, it means that they want to find out that which of the following organisms are motile. All right, and you should know examples of motile organisms. For example, E. coli is motile, Proteus is motile, Klebsiella is not motile, and so forth. So if they add, they give you a list of organisms, and they say which of the following will show positive for hanging drop, instead of saying which of the following organisms are motile, we'll say which of the following organisms will show positive for hanging drop. Okay, I hope that that question can easily be answered, especially at the diploma level. All right, and then when they give you a list of organisms, look out for those ones which you know to be motile, and those ones which you know not to be non-motile. And then you are free to go with your answers. Any question or any misunderstanding? If you cannot do the hanging drop method, just follow the procedure and know that hanging drop test or hanging drop method is a test for motility of bacteria. Okay. So if they ask you a question about which of the following organisms will show positive for hanging drop test or hanging drop method, all they want to know whether you can differentiate between organisms that are motile and organisms that are not motile. That is all that I'm talking about. All right. There's also a certain procedure in microbiology. Of course, technically it is in parasitology. Okay, it is in parasitology. And because I want to touch on some small procedures, I decided to also touch on this. There's a procedure called the cellophane tape test, or the cellophane tape preparation. We also call it the Scotch tape preparation. So cellophane, I'm sure all of us know about what we call sellotape. Sellotape. It is actually called cellophane. Cellophane. Right. The Scotch is just a name to attaching to the cellophane. Now, if you look at the picture you are seeing now, what can you say about it? Anybody with, I'm sure the picture is here. Can somebody tell me how they look like?
They look like schistose egg.
Okay, that is how you see it. Has anybody else? How do you see this X? Yes, anybody with a different idea?
They also look like a dowry.
Dowry, okay, that's good. Yes, how do you see them? Anybody with a different view? Where's my Portia? Portia, are you there?
Yes, sir.
Okay, so how do you see what is on the screen?
Okay. So I just joined, so let me think.
Okay, all right. So if you look carefully, let me see if I can give it some hand. You see that it is asymmetrical. When you say something is symmetrical, it means that if you divide it into two, one half will be the same thing as the other half. Do you understand that? If something is symmetrical, then it is, if it's oval, if you cut it into two, one half will be the same thing as the other half. If you look at this carefully, you see that one half appears to be flattened. And then this half is the where you have it as a curve. You have this side as a curve, and then you have this side almost flat. So see, one side is almost flattened, then that side is curved. If you look here, this side, you see it as a curve, this side is flattened. So we say they are asymmetrical. They are not, so that it means that if I cut this into two, like this side will be different from this side. Okay, this side will be different from this side. So in the first place, it is asymmetrical. Right. If you look at it carefully, you see that there seems to be a labia inside. This is a labia which is inside an ova. This is supposed to be an egg, but you see, a typical egg is oval. A typical egg is oval, but this one, it is one side is flattened and the other side is the curve. So this is classical of Enterobius vermicularis. Enterobius vermicularis, which you call the pinworm. Okay, this is classical, even though we are doing, all right, we appear to, we are doing bacteriology, but you know, the whole thing is about microbiology. So microbiology also includes parasitology. So this aspect is purely parasitology, but I want you to just try and understand it, that this is an ova, but it's not a classical ova. The classical ova is always oval. An ova is oval, where once you cut it into two, one half will be equal to the other half. So some, we say that they are symmetrical, symmetry. Okay. Now this one deviates that description of ova. Okay, so it means that this one is asymmetrical. One side is flattened and the other side is curved. So it doesn't follow the characteristics of a typical ova. I hope that you are following me, please. Now, I'm saying that this is typical of Enterobius vermicularis. Okay. You will never find Enterobius vermicularis in stool. You can tell me why. It is one of the intestinal parasites, all right. How come that you never find Enterobius vermicularis in stool? Who can tell me? Anybody who can tell me, I will give the person, can see this Momo. Hey, not Momo. What do you call it? Data. Can see this word of data. Why is it that even though Enterobius vermicularis is HAEM, and for that matter, it's intestinal, and therefore you're expecting to find it in the stool, why is it that nobody finds Enterobius vermicularis X or over in stool? Why? somebody should try. If you try and you get it correct, you get 10 cities data. If you don't get it correct, I mean, you don't lose anything.
The eggs get stuck or pinned to the anus.
Who is speaking? Godfred or Sammy?
Samuel.
Come again.
The eggs are pinned to the anus.
The eggs are pinned to the anus.
Yes.
Well, to a large extent, well, I think you are not too wrong, but technically too, I won't take it. Anybody to
Hello, sir.
Yes, sir.
Sir.
Please,
Yes, sir.
the eggs are deposited on the perianal area.
Fantastic. The eggs are deposited in the. Who is this person?
Sebastian.
Sebastian. Okay, I'll send you after the letter. I'll send you sensitive data. Okay.
Okay, thank you, sir.
So the eggs are deposited at the perineal area, and then the flattened portion. Okay, the flattened portion is adhesive. Okay, the flattened portion is, let me put the is sticky. So the eggs are laid at the perineum, and then the flat portion, this portion, the flattened portion is very sticky. So they stick to the anus. And therefore, when you pass through, they will just be stuck there. And that's why you don't get them in stew. You never get them in stew because of this kind of characteristics. All right. So that's how it is. So you don't get them in stew. So if you don't get them in stew, and a doctor is suspecting enterobiasis, who can tell me? Okay, let's move on. So if a doctor is suspecting this, and then he writes a clinical diagnosis, enterobiasis or pinworm infestation, and then he brings it to you into the lab, what are you going to do? Knowing that whatever you do, this X will not be found in stew. Meanwhile, the doctor is suspecting it. So what will you do? So that is where this cellophane tape method comes in. Cellophane tape method comes in. So if there's a strong suspicion of enterobiasis or enterobiasis, which is pinworm infestation, if the doctor is suspecting it, and it brings you, and even the doctor writes QRE, okay, meanwhile the diagnosis is a pinworm infestation, okay, you will see that yes, the doctor doesn't know. So you, the scientist, should know better that if the doctor is suspecting pinworm infestation and he has suspected QRE, the report will always be negative. So you do the cellophane tape test. There is a special cellophane, not the one that even though it's a solid one people call sellotape, but this one is special to the extent that it is not the normal one we find on the market, which usually looks like yellowish or something. No, this one is pale. It's almost like white. Okay, it is white. Right. So what you do is that you do the cellophane tape test, and this one you just sometimes you also call it the anal tape, where you ask the child. Normally, the children that get infested with pinworm infestations, okay, or enterobiasis. So in the morning, before the child defecates, you don't allow the child, you ask the child to come to the lab first thing in the morning, and then try not to have defecated, because if they go to defecate, normally they rub their anus or something, and then probably you can disrupt a lot of the eggs. So while the child has not defecated, you just ask the child to bend down. So you use the tape, the adhesive portion is used to tap the anus, okay? So you stretch it, and then the adhesive portion, you use it to touch the perineal area. You touch it. So the concept is that the eggs which have been laid there, the sellotape, the adhesive portion will pick it up. So when it picks it up, then the sellotape is now going to serve as your cover slip. So you put the sellotape also on the slide. Meanwhile, remember that it is the adhesive portion. So the adhesive portion is where you use to tap the perineal area of the child. So you put that same adhesive portion on the slide, okay, so that the non-adhesive part is on top, and then it is going to serve as a cover slip, okay, because that's why I'm saying use the special sellotape that has that is plain, so that it will serve like as if it is a cover slip. Then you examine. So once you examine, you are going to get something like this in this picture. So if in examination, sometimes they can just give you a picture like this. Then they ask you what method is this? The only way you can get X, and you should know that these X are typical of enterobius, because like I've said, enterobius X are asymmetrical. One side is flattened, one side is rounded. So you should get this picture in mind, that this is typical of enterobius vermicularius X. And the only way you can get enterobius vermicularius X plentiful like this is through the cellophane test. The cellophane test. There's no way you can get them in these numbers in a stool sample or in any other sample. So if you have a picture like this and they ask you what test or what procedure is this, you know that this is cellophane tape test. Okay, or the anal, sometimes depending on how the question is put, you can make it anal tape test. Anal tape because you are using the tape on the ends. That's all. Right. Any question or any confusion? Hello. The man who gave me the good answer, when you finish, send me hi, and I'm sure you have my number. You have my number.
Yeah, okay. I will send you. I don't have a number, but I'll
Okay.
get it.
Okay.
Yeah, okay.
So send me hi so that I know I get your number correct, and then I honor my pledge. Okay.
Okay. Thank you, Grandpa.
Welcome. Right. Any question on this slide, please? All right. Okay. So we move on. Hello.
Grandpa.
Yes, sir.
Yeah, please, I would like to know, is it only in the pinworm that we use the cellophane tape?
Yes, as far as I know, yes, because it is only the pinworm that lays its eggs in the perineal area. All others, all the hermits, the eggs will be found in the stool. Okay, eggs will be found in the stool. It's only in the enterobius that will lay its eggs in the perineum, and because the eggs the eggs are flattened, the flattened portion is sticky. It will stick in the perineal area, and it will not come out. Okay, so that's the only way you have to apply this. Sometimes, and probably at high level, sometimes they can ask you which ova can be found in, let's say, high vaginal swab. Okay, you see, because especially in children, okay, and once the eggs are laid at the perineum, they cause pruritus ani. I'm sure you know this. Pruritus is itching. Ani is the anus. So they cause, and so you see a child with the hand in the anus scratching profusely. Okay, so if you have a child, a small girl with pinworm infestation, sometimes they will scratch to the extent that they will push the scratching and said that it will then, and then they will push some of the eggs to the vulva area. Okay, so once they push some of the eggs in the vulva area, inadvertently, they become, lodged in the vagina. And then it can also be itching as if it has candida infection. So you can go and take vaginal swab only to find something like this in the what do you call it, in your preparation. So if you don't know, you say either you may ignore it, but if you know, you will say that this is enterobius vermicularis ova that are found in the vagina. And it means that the child has it, is scratching and then pulling some of the eggs to the vulva area and then has become part of the vagina, become part of the vaginal sphere. And then that's where you get it. So depends on the level. So at high level, for example, MLSD level, probably that's a question that they can ask, that which type of ova can be found in vaginal sphere, for example. And the answer will have the enterobius vermicularis. Okay. Can we move on? All right. So that was just something on basic principles. So you are now going to have a look at some of the common media. And I keep on saying that this is preparatory platform, especially for the diploma people. That is still good for the MLS and the MLSD too. Now, one of the commonest media we use in microbiology is sheep blood agar. Okay, sheep blood agar. And with sheep blood agar, you know that you can use nutrient agar as a base. You can use brain heart infusion agar as a base. You can use Columbia agar as a base. You can use any of the what we call basal media. Okay, nutrient agar where they don't contain so many of nutrients. They become your basal media. And then when you add blood, it becomes blood agar. So the normal percentage of blood to add is 5%. So 5% will mean that if you have, let's say 500 mils of media that you have prepared, 5% will be just about how much? 50 mils, 50 mils. So you add 50 mils of blood into the 500 agar base that you have prepared. That's all. And that will be enough for your sheep blood agar. Okay, right. Now, how is it used? So it is used in the isolation of common fastidious bacteria. When we talk about fastidious bacteria, we're talking about bacteria that will require some enrichment, that will require some high nutrients. And you know that blood is very, very nutritious. Okay, so therefore, when you have blood in a media, they support the growth of bacteria that require a lot of nutrients. Okay, so they are used for isolation of fastidious bacteria. Right, and then it is also typically used in the classification of Streptococcus. You see, Streptococcus demonstrate hemolytic properties. And if they show complete hemolysis, that's the beta. If they show partial hemolysis, that's the alpha. If they show no hemolysis, that's the gamma. So it is beta hemolytic, alpha hemolytic, and then the gamma hemolytic. And so normally they can ask you, and still at the diploma level, they can ask you which organism, okay, is classified based on its hemolytic properties on blood agar. All right. And that will be what we call a streptococcus. That's why I put here example streptococci. So streptococci, once it goes on sheep blood agar, okay? Once it goes on sheep blood agar, then we can classify it as beta hemolytic. Then that's where you have the BHS. BHS is beta hemolytic strep, okay? Then you can also have the alpha hemolytic strep and so forth and so on. So it is good for classification. I'm talking about the sheep blood agar. It's good for the classification of streptococcus. Okay, right. Then we move on to chocolate agar. When the blood agar is heated, it turns brownish. When blood agar medium is heated, it turns brownish. It is this brownish color which is giving this medium its name as chocolate. So it doesn't mean that when you prepare chocolate agar, you add a certain chocolate amount of chocolate to it. No, it is when the blood has been heated, the blood will get lice, and then it will turn color to become brown. So it is, once again, it is the brown color which gives the name as chocolate agar. All right. Now, you see that when you are heating the blood, it will lyse, as we said. When it lyses, certain nutrients which are intracellular, which are within the red cells, will now be exposed. Okay, so for example, Haemophilus, I'm sure you know about Haemophilus. Haemophilus, the word heme means blood, phil means lab. So Haemophilus is an organism that loves blood. So it loves blood to be able to grow, to be isolated. However, it doesn't grow on blood agar. Who can explain? Haemophilus loves blood, and that's why it is even called Haemophilus, the blood loving. However, if you put it on blood agar, it will not grow. Who can tell me? Also, for another 10 series data, if Haemophilus loves blood, that's why it is called Haemophilus, blood loving. However, if you plate it on blood agar, it doesn't grow. Why? Somebody should try.
Because the cells are not sliced, or there was no heat that was subjected.
Okay, not bad, but that will not be sufficient to get to the bundle, the data. Yeah, somebody else, anybody? Yes, just try, just try. Somebody should try. The question is, Haemophilus is so called, it's called Haemophilus because it loves blood. However, it doesn't grow on blood agar. Why? All right. So, like I've said, and as the name implies, Haemophilus loving blood. Now, what it actually needs or requires from blood are factors that we call, it is designated as X and V. The X is the hematin or the heme, and V is NAD. I know NAD is nicotinamide adenine dinucleotide. These are the classical things in blood that Haemophilus loves. That's what it requires to grow. However, these things, the hematin and the NAD, they are all within the red cells. Okay, and because they are within the red cells, yes, the Haemophilus loves it. but it doesn't have mouth to break into the organism, so into the blood and take the X and V factors. It doesn't have that capacity. And so, yes, it loves the blood. But what it loves about the blood is its X and V factors, which are all intracellular. And so that's why they don't grow on blood agar, because the things that they love are within the cells. Now you see that Hemophilus will grow on chocolate agar because in chocolate agar you are hitting the blood, and then the X and V factors, the X factors is the hematin. The hematin is the hemoglobin, okay? So they'll be released. And then NAD2, which is also intracellular, will also be released. So within the chocolate agar, the X and V factors are released. And because they are released, they become available. That's how come Hemophilus grows very well on chocolate agar, but doesn't grow on sheep blood agar. But the same thing, the same sheep blood agar, which has just been heated to give you the chocolate. Once it has been heated, the cells are hemolyzed, they release the X and V factors, the Hemophilus will use it and then grow. So that's the simple explanation. Okay, right. Now the chocolate agar is also important to grow Neisseria. So the two organisms which will or normally will not grow on blood agar, but grow on chocolate agar, will be Neisseria and Hemophilus. So take note. So it depends on how the questions are set. Okay. So if they are talking about the importance of chocolate agar over sheep blood agar, then the fact is that certain organisms which will not grow, fastidious organisms which will not grow on sheep blood agar but grow on chocolate agar include Hemophilus and Neisseria. And I'm sure once you understand this, you can always answer questions relating to chocolate agar and sheep blood agar. Right. Then there are other few other media which you must have an idea about. Okay. Now, there is this media XLD, DCA, and SSA. I'm sure you are familiar with them. XLD is xylose lysine deoxycholate. And then DCA is the succinylate citrate agar. SS agar is Salmonella shigella agar. You are very familiar with this media. They are all used for stew cultures for the isolation of Salmonella and Shigella. What you are not too familiar with is the heptoin enteric agar. Heptoin enteric agar is also a very good media for the isolation of Salmonella and Shigella. So in developed countries, they don't use XLD, DCA, SSA, they don't use that. Rather, they use the HEA, which is heptoin enteric agar. So you should have this in mind, that a media called heptoin enteric agar replaces SS agar and DCA and so forth. They are better isolators. They better isolate Salmonella and Shigella more than the DCA and the SS agar. So in developed countries, they use the heptoin enteric agar. So, and this question they can even ask at the high level because they want to find out whether you know that apart from the DCA and SS agar, you can also have other media which is useful for the isolation of Salmonella and Shigella. So not just for the diploma level, but SS level, MLS and MLSD level too. I'm sure it is something that you have to know. The good thing is that for all the media for stew cultures, you all have what you call thiosulfate. Thiosulfate, a lot of the Salmonella and Shigella they are able to produce what we call A2S. Okay, once they produce A2S, the A2S that they produce will combine with sulfate and give you a black coloration on the media. So as soon as you see blackening of the media, then you know that it's likely to be Salmonella. Shigella doesn't produce A2S, the Salmonella does. So if you see a lot of colonies with blackening on top, then you know that this is likely to be Salmonella. All right, so that is a way to differentiate between Salmonella and Shigella, for example, on your plate. All right, so I'm also sure you know a lot about Muller-Hinton agar. Muller-Hinton agar is the medium for sensitivity testing. You cannot use any other media for sensitivity testing, but Muller-Hinton. I'm sure some labs use nutrient agar for your sensitivity. This is not acceptable because all of us know that once you have done your sensitivity test, you measure your zone of inhibition. When you measure your zone of inhibition, you are going to compare this one with a standard chart. Okay, this standard chart is produced by a standard company called CLSI. I'm sure you know about CLSI. CLSI is Clinical and Laboratory Standards Institute. They produce the requirements for a lot of the laboratory procedures. And so they also have requirements for doing sensitivity. So if you don't follow their requirement and you do your own procedure anyhow, then at the end of the day, you cannot compare your zone of inhibition with their chart, because you cannot do, let's say, your research, use a certain method here. Somebody has also done another research somewhere with a different method. When you finish, you want to compare your results with that research. It will not work. Okay, so CLSI have set a certain standard. And it is based on that standard that they generated the chart. Okay, so if you want to compare your zone of inhibition in your lab with that chart, you must go by their requirements. Okay, and one of the key requirements is that you must use Muller-Hinton. So they use the Muller-Hinton to do the testing. So you can't go and use nutrient agar or some other media and then do your sensitivity, take your measurement and go and compare with the standard chart. That will not work. So the standard media for performing AST is Muller-Hinton agar. Keep note. Again, CLSI requires that if you are pouring your agar, you are pouring the Muller-Hinton agar, the depth of the agar, I'm sure you know that if you put media, if you are preparing media, you put it in the plate. I'm talking about a petri dish. It will set or to solidify. When it says it will give you a certain depth, to give you a certain depth. That depth is prerequisite that if you're doing the sensitivity, and for that matter, using the Muller-Hinton, that depth should be 4 millimeters. It is also a requirement by CLSI. So you also have to know this, because sometimes they can ask questions around that. Sometimes it can say, oh, which of the following statements about AST is correct or is false? Then they will say something like, oh, the required depth of the medium should be, let's say, 5 millimeters. They know that that is wrong, because the required depth should be 4 millimeters, something like this. Okay, right. The next thing is on mannitol salt agar. I'm just touching on some few media where they normally ask questions around. Okay, right. So mannitol salt agar. Mannitol salt agar is also, sorry. Mannitol salt agar is a medium which contains, like salt, contains a lot of salt. Okay, and the high salt content becomes inhibitory for a lot of other organisms. So, because most organisms don't like high salt content. So, if you are preparing an agar with very high salt content, then the salt content becomes inhibitory, so that other organisms will not grow. But salt content, high salt content, Staphylococcus can easily grow in it. Okay, so it means that if you have mannitol salt agar, it will be good to use it as a selective medium for Staphylococcus. Now, if you add the mannitol is also one of the carbohydrates. So Staph aureus can also ferment mannitol. Okay, so it means that on mannitol salt agar, you can easily isolate or differentiate Staph aureus from other organisms. That is all. Okay, that is all. Right. So I'm just touching on small areas which can be used to answer questions. Okay. Then here you're talking about McConkey and sorbitol McConkey. I'm sure all of us know about McConkey, that it is the medium that is used for the isolation of almost all the gram-negative organisms in the GIT or in the gut. And for that matter, they are used for the isolation of Enterobacteriaceae. Enterobacteriaceae is the group of organisms that inhabit or inhibit, that reside within the GIT. And McConkey is a medium that is used to isolate them. All right. Now, we know that the chief organism in the Enterobacteriaceae group is E. coli, okay? Now, so E. coli will definitely grow on McConkey. And E. coli is a lactose fermenter, okay? And because it is a lactose fermenter, organisms that ferment lactose, and for that matter, carbohydrates, gives acidic products. So if carbohydrates is fermented, the end result is an acid production. Now, so the indicator in McConkey is neutral red. Neutral red becomes red in acid environment. And for that matter, lactose fermenters will become red. All right. So lactose fermenters like E. coli will appear reddish or pinkish on McConkey agar. Okay. There is something you have to know. McConkey agar is both inhibitor or inhibitory organism. McConkey agar is both a differential medium and a selective medium. Who can explain that McConkey agar can be described as both a differential medium and a selective medium? Who can explain?
Sir,
Yes, sir.
for McConkey, we are seeing a selective because it's only meant for growing of gram-negative organisms. And then differential in the sense that it differentiates the lactose fermenters from the non-lactose fermenters.
You've done well. It's a differential medium because it contains lactose and therefore can differentiate between lactose fermenters and non-lactose fermenters. The other aspect is that it is selective because it contains bile. I know we are going to talk about isolation of the Enterobacteriaceae, organisms that are in the GIT. Organisms that are in the GIT are exposed to bile. I'm sure you know about bile. Hello? I'm sure all of you know about bile. Bile production, bile which is excreted through the bile duct into the duodenum to help in the metabolism of fat. I'm sure you know this. Hello? Yeah. So it means that organisms in the GIT, they are used to bile environment because the bile, once it comes into the GIT, it flows through, and so it means that all the enterobacteria are used to what? The bile. So if you prepare a medium and you add bile, do you think that the bile will kill the enterobacteria? If you have medium that contains bile, will it kill enterobacteria?
No.
No, it will not kill them. It will only kill organisms that are not used to the environment of the bile. And those are the gram-positive. You know that normally in the GIT, you have the gram-negative organisms, gram-negative ROS. Okay, so the gram-positive organisms, they are normally not in the GIT, and therefore they are not used to the environment of bile. And therefore, if you prepare a medium like maconke and you introduce bile, they will be inhibitory, they will kill, what do you call it, all gram-positives. That's why maconke do not support the growth of gram-positive organisms. Once they don't support the growth of gram-positive organisms, it means that they are now become selective. So maconke is selective due to the presence of what? Bile. The bile is inhibitory. It's inhibiting the growth of all the gram-positives, whilst allowing the growth of the gram-negatives. That's all. Is that all right? Good. There is also a medium called the sorbitol maconke. That's what I have, yes. There's SOR MAC. The SOR MAC is sorbitol maconke. Sorbitol maconke. Who has an idea or information about sorbitol maconke? Any idea or information about sorbitol maconke? Please, these things, you have to know them basically because, especially for the diploma level, the question they will ask about media is just about the things that you're talking about. And at the higher level, talking about the MLS and MLS level, then aspects like sorbitol maconke will come in. The sorbitol maconke, they'll think that it's too high for the diploma level, but it should not be too high for the MLS and the MLSD level. So, but I just wanted to know that maconke can be described as selective and differential. Differential because it contains it contains lactose that can differentiate between lactose fermenters and non-lactose fermenters. The selective because it contains bile that will inhibit the growth of gram-positives, first allowing the growth of the gram-negative ROS. Okay, that's why it is selective. Now, what about sorbitol maconke? Does anybody have an idea about sorbitol maconke? Sorbitol maconke for 10 cities data, please. Where is my Portia? Auntie. Oh, I hope my Portia is online.
I'm online.
Yeah, okay. Can you have idea about sorbitol maconke? Okay, all right. Don't worry. Anybody to her rescue? Okay. Sorbitol maconke is a modification of the normal maconke. And what happens is that the lactose in sorbitol, the lactose in maconke The norm, I've told you that normal macronutrient contains lactose. That's why you can differentiate between lactose fermenters and non-lactose. Then the normal lactose in macronutrient is replaced with sorbitol. The normal macronutrient contains lactose. Sorbitol macronutrient replaces the sorbitol is used to replace the lactose in the normal macronutrient. So we call it sorbitol macronutrient. Okay. Now, so here you see that our fermentable carbohydrate is now sorbitol. It's not lactose. Our fermentable carbohydrate in the sorbitol macronutrient is sorbitol and not lactose. Please take note. Now, all E. coli from the E. coli from GIT is supposed to be normal in the GIT. However, a certain strain of E. coli has been known to be pathogenic. Okay, a certain strain of E. coli has been known to be pathogenic, and that E. coli is called E. coli 0157. Not 0, it's 0157 and then H7. Remember, the O is about the somatic. You know, if you have bacteria, a rod which has a flagella, okay, then the antigens on the bacteria, we call the somatic antigens, is represented by O. And then the antigens for the flagella is represented by H. And since E. coli is motile, you know, E. coli is motile, it means it will have O antigens and then the H antigens. So this has been classified, okay, or characterized, and then the O for this particular E. coli has been classified as O157. And then the H for this particular E. coli has been classified as H7. So in all, we have E. coli O157 colon H7. Okay. E. coli O, not 0, O for somatic, O157 colon H7 with flagella 7. This E. coli O157 H7 has been known to be pathogenic. This E. coli O157-7H has been known to be pathogenic. Since it has been known to be pathogenic, then it means that if you get E. coli from stool, okay, you have to find out, is it the normal E. coli or this strain of E. coli called E. coli O157? Now, the medium or the media which has been used to distinguish between the normal macronutrient, the normal E. coli and E. coli O157 is the sorbitol macronutrient. The idea is that all E. coli will behave as lactose fermenters on macronutrient, including E. coli O157. Every macronutrient will show pinkish colonies of the E. coli. So whether this E. coli O157 or normal E. coli, it will appear pinkish colonies. The colonies will be pinkish, and therefore they are lactose fermenters. Now, all the other E. coli will also ferment sorbitol, except E. coli O157. Please take note of this very well, especially the MLSD people. All right, sorry. I'm told that you can't see my slide. Is that it? Hello? Hello?
Hello, sir.
Hello, sir.
I'm getting the listen that you can't see my slide. Is that it?
It's showing.
Okay, thank you.
Where you are missing from, please.
Yeah, so except that a lot of the tokens are not captured on the slide. I'm only showing McConkey and Sobito McConkey. All the rest is just about speaking. That's why I'm saying that in my lectures, if you want to rely on the slides, you won't get anything. Okay, so just follow the lecture, and then you get all the information that you want. I'm saying that they normally will ask some simple questions regarding media. Okay, they'll ask simple questions regarding media, especially at the diploma level. I'm saying especially at the diploma level because they think that as for media is so fundamental, and therefore the diploma level graduates should be able to handle media. Okay, but there are certain types of media which is probably unique. Okay, and therefore they ask questions at the MLS and the MLSD level. That's why I'm introducing this aspect for you. Right, so I'm saying that McConkey is one of the commonest media we use in microbiology, and it's used both as a selective medium and also as a differential medium. Now I'm saying that you should know why it is selective and why it is differential. And this is also a very simple question they can easily ask. Why is McConkey differential? It is differential because it contains lactose, and therefore lactose fermenters and non-lactose fermenters will show different colors on the McConkey. All right, and therefore it becomes a differential media. Why is this selective media? It is selective because it contains bile salt, and bile salt is inhibitory to gram-positive organisms. But bile salts will not kill or will not inhibit the growth of gram-negatives because the gram-negatives, which are in the GIT and the enterobacteria, they are exposed to bile already in the GIT because bile is usually poured through the bile duct into the duodenum and then of course into the intestinal tract, and therefore bacteria in the intestinal tract are used to the environment of bile, and therefore if you prepare a medium that contains bile, they will not kill gram-negative rods. They will not kill them. Okay. However, you will see that when you look at the GIT, you don't have gram-positive organisms in the GIT. Therefore, gram-positive organisms are not used to the environment of bile, and therefore, if you prepare a medium that contains bile, it will kill them. It will inhibit their growth. That is why gram-positive organisms don't grow on McConkey. So you see that strep will not grow on McConkey, staph will not grow on McConkey. Okay, and so those are the fundamental principles. And when they ask questions, that's how they ask the question to find out whether you know the principle. Okay, right. And I'm saying that so E. coli will automatically grow on McConkey, and on McConkey, E. coli is a lactose fermenter. Okay, and therefore it will show as pinkish colonies on McConkey. Simple. Good. So and everybody can detect or can identify E. coli on McConkey. We are saying that there is a strain of E. coli which is now beginning to be pathogenic. So normally if you get E. coli from stool, you will not work on it because E. coli is normal in stool. However, there is a certain strain of E. coli which has been classified as E. coli 01577H. E. coli 01577H is pathogenic. Since it's pathogenic, we should find a way of classifying or differentiating it from the ordinary E. coli. And that's where Sobito McConkey comes in. What is Sobito McConkey? Sobito McConkey is the same McConkey, but instead of lactose in McConkey, the McConkey has been removed. Sorry, the lactose has been removed and replaced with sorbitol. Sorbitol 3 is a carbohydrate. Okay, but a rare carbohydrate. What happens is that all the E. coli, every E. coli can ferment lactose, but not all the E. coli can ferment sorbitol. And the typical example is the E. coli 0157. The E. coli 0157 cannot ferment sorbitol. It's a sorbitol non-fermenter. And since the sorbitol macronke doesn't contain lactose, they contain sorbitol, it means that on sorbitol macronke, E. coli 0157 will behave as a non-lactose fermenter. I don't know whether you are getting it. The sorbitol macronke, the sorbitol is replacing the lactose. And ordinary E. coli will ferment sorbitol. So the ordinary E. coli will also behave like a lactose fermenter as far as on sorbitol macronke. However, E. coli 0157 cannot ferment sorbitol. So that it means that on sorbitol macronke, the E. coli 0157 will behave as a non-lactose fermenter. And therefore, you know that normally on the macronke, non-lactose fermenters are pale, almost colorless. So it means that on sorbitol macronke, E. coli 0157 will behave like a non-lactose fermenter, which is also pale and colorless. So if an organism was a lactose fermenter on macronke and therefore pinkish, when you subculture it on sorbitol macronke, it is becoming pale and pale. Then it means that that organism is E. coli 0157, as simple as that. So it means that the sorbitol macronke is becoming like your how do you call it? Your classical indicator. Okay, classical indicator for isolating sorbitol, for isolating E. coli 0157. That's all that I can say. But it depends on how questions are set. I'm sure that once you have this idea, you'll be able to figure it out. So I'm saying that sorbitol macronke is used to differentiate and for that matter, confirm the identification of E. coli 0157 because they are non-sorbitol fermenters. Because they are non-sorbitol fermenters, they will behave like non-lactose fermenters on the sorbitol macronke. Because in sorbitol macronke, you don't have lactose. The lactose is being replaced by sorbitol. And E. coli 0157 cannot ferment sorbitol. Therefore, it will behave as a non-lactose fermenter, which will be pale, colorless on the sorbitol macronke agar. As simple as that. I hope with this explanation, no question on this can beat you. Right, then TCBS, I'm sure you know this one. TCBS, thiosulfate citrate biosol sucrose agar. TCBS, thiosulfate citrate biosol sucrose agar. And this is the media for the isolation of Vibrio. Media for the isolation of Vibrio. So if there's a case of suspected Vibrio, then first and foremost, we normally would take rectal swabs. If there's a suspected case of cholera, you take rectal swabs. And the rectal swab is initially put into what we call alkaline peptone water. Alkaline peptone water. In alkaline peptone water, you know, Vibrio is an alkalinophile. Vibrio organism is an alkalinophile. It means that it lacks high content of pH. And most of the organisms we work on are neutrophiles, not neutrophil, as in hematology. But neutrophile means that they like neutral pH. So a lot of the media we use in microbiology have a pH of about 7.2 plus or minus 0.2. So it means that it is still around neutral pH and also around the pH of the body. You know the pH of the body is around 7.4. So those organisms that will cause disease are used to live in environments which pH is around 7.4. So most media have that kind of pH. Now, however, Vibro is an alkalinophile and therefore survive in very high alkaline pH. So for example, the pH of TCBS is always around 8.6 plus or minus 0.2, which is getting to around pH of 9. And this is highly alkaline. And therefore that high alkaline pH will not allow the growth of normal other bacteria. All right. So if you prepare peptone water, you know peptone water is a basal medium. Any organism can grow in peptone water. However, if you alkalinate it, if you add sodium hydroxide to your peptone water, it becomes alkaline peptone water. Then now it has become inhibitory to the other organisms, whilst allowing the growth of vibro. So it means that alkaline peptone water is an enrichment medium which will suppress the growth of other bacteria whilst allowing the growth of vibro. To allow the growth of vibro because the high alkaline pH can only support the growth of vibro, which is an alkalinophile. All right. So the primary rectal swab, the rectal swab that you get should first and foremost be put into alkaline peptone water. After a while, about 6 to 8 hours, then you subculture onto TCBS, which is the selective medium for vibro. TCBS2 has a pH of around 9. Okay, and that one too is to prevent the other bacteria from going, and then the vibro will grow, and then you pick it up from there and then do your identification. All that I want you to know is that TCBS is the selective medium for isolation of vibro. TCBS has a high alkaline pH because vibro is an alkalinophile and therefore will support the growth of vibro whilst suppressing the growth of other bacteria. Okay, right. The next media to talk about is SDA, Sabrod dextrose agar. This one too is the culture medium for fungal growth, or for fungal cultures. One thing you should also know about Sabrod is that Sabrod is, no, before we move on, fungals are acidophiles. So you know we have talked about alkalinophiles, that those that live or grow at high alkaline pH. Typical example is the vibro. Then we have the neutrophiles, those that grow around the normal body pH. And almost all the organisms are of that nature. Okay. And then we have the acidophiles. The acidophiles, the fungus. Fungus are acidophiles. They rather will love acidic environment. They love acids. All right. So SDA, Sabrod dextrose agar, has a pH of around 5. So you see the difference now, that the normal media has a pH of around 7.2. Okay. Then TCBS has a pH of around 9. So that makes it an alkalinophile. Now we have SDA, which has a pH of 5, which is also an acidophile. So it will also support the growth of fungus. So you see that pH can play a role. And so depending on the media and then what kind of organism you want to grow, the pH can be modified. So what I'm saying is that SDA, which is Sabrod dextrose agar, is for the growth of fungus. And the pH of SDA is around 5 because that is the pH that will support the growth of fungus. Fungus are acidophiles. And that is why, how come Candida will also grow on SDA, because Candida also has semblance of fungus. That's why Candida can easily grow in the vagina. You know that vaginal pH is around 3.8 to about 4.2. That's highly acidic. But that's what the fungus like. And so Candida will conveniently grow in the vagina because the Candida normally, just like all fungus, is acidophilic, and therefore they will find it comfortably growing very well in the vagina. All right, so that's how come fungus cultures will use SDA that has a pH of around 5. And that's also how come Candida can conveniently grow on SDA because of the acid content. Okay, good. There is this media, which everybody also knows, the clade medium. Clade is cysteine lactose electrolyte deficient agar, or some will just call medium. Cysteine lactose electrolyte deficient, which by abbreviation is clade. Now, clade is used for the isolation of urinary pathogens. Okay, it will grow all pathogens from urine. So any organism that can cause UTI can grow on clade. Okay, so that's why we use clade. So if you don't have clade and you are going to use McConkey, what must you do? I'm saying that clade is used to culture urines, and all the urinary pathogens can grow on clade. My question is, if you don't have clade in your lab, what is the alternative? And let's say you want to use McConkey, what must you do? If you don't have clade in your lab and you are using McConkey, what must you do? Yes. Hello. Somebody should try it.
So you use Sorbitol.
No, because you have heard about Sorbitol. No, Sorbitol there exclusively for E. coli 0157. Please don't make that mistake. Sorbitol McConkey is exclusively for E. coli 157. 0157. Okay. All right. Let me help you here. I don't want Abraham want to try. Abraham.
So you can modify the pH.
You modify the hello.
The pH.
The pH. No.
Yeah, you can modify the pH.
No. All right, let me help you. If you don't have clade, okay, and you are using McConkey, you must add blood agar. You must add as simple as that. If you are using clade, you don't need to add blood agar because all the organisms in the urine, all causes urinary tract infection, all of them can grow on clade. Remember, you said that McConkey will not support the growth of gram positives, and for that matter, strep and what do you call it? And staph will not grow McConkey. Do you remember that? So if you use McConkey alone for your urine, what if the urine is infected with staph? It means that you are going to get no bacterial growth. Okay, so it has to be supported with blood agar. In the absence of clade, if you are using blood agar, in the absence of clade, if you are using McConkey, the McConkey should be supported with blood agar because McConkey is inhibitory to or will not support the growth of the gram positives. Therefore, you must bring in blood agar to pick up the other organisms which McConkey will not grow. So take note on that one too. All right. Now, clade cysteine lactose electrolyte deficient agar. What is its purpose? All right, let me, because of time, let's move on. You know, in urine, when you culture urine and you get isolates, you are going to do what you call viable count. You are going to do colony count. You are going to count the colonies, okay? Because urine, there should be a certain threshold. There should be a certain number of organisms per ml of urine to be declared as significant. So what it means is that if you have a growth from urine, you must count the colonies and determine whether they are up to the threshold. And the threshold is, I'm sure all of you know, 10 to the power 5 colony forming unit per ml for urine. 10 to the power 5 is about 100,000 colonies per ml of urine for it to become significant. So it means that you are going to count the colonies. However, remember that we said that you are going to count the colonies. And Proteus, you know that Proteus is also one of the organisms that can cause UTI. In fact, all the organisms that comprise or consist of the Enterobacteriaceae, all of them can cause UTI. Because in the GIT, they are okay, they are normal. If they move from the GIT to the urinary portion, genital side, they can cause infection. And that is why, how come females get more UTI than males? Because the proximity of the perineal area to the vagina. And therefore, they can easily get organisms within the GIT. When you have defecated, the perineal area gets contaminated. And especially if you have ladies that wear tight panties and the G-strings and so forth and so on, you will see that as you walk, you are likely to transfer some of the fecal material from your perineal area to the vulva area, the vaginal area. And that's how come you get the infection. Okay. Right. So almost everything within the GIT can move to the genital urinary area and cause UTI. Okay. And one of the bacteria in the GIT is Proteus. What I'm saying is that Proteus swarms. I'm sure you know about swarming. Please, what is swarming? Proteus swarming. Yeah, somebody help me. What is Proteus swarming? Please, let's hurry up. What is Proteus swarming? Anybody with idea? Proteus swarming of Proteus. Mabna, who is Mabna? Mabna, I love mentioning the names of the ladies. Who is Mabna? Is she on the line? Is Mabna on the line?
Yes, please.
Okay. What level are you, please?
It's MLS.
MLS, okay. So what is Proteus swarming?
Please, it's related to their movement, like how they are spread on.
Very good. So,
I don't know how.
Come again.
I was like, I didn't know how to put it out.
Oh, but you've done well. It is
okay.
The spreading of the colonies of this on the surface of the plate, so that if you have few colonies of Proteus here, at the end of the day, they will just spread throughout the entire plate. That's the swarming. And due to their hypermotility, you know, proteus is highly motile. And so because they are highly motile, even though the plate is a solid plate, yet they are still able to move. So you have it moving all over, and they cover the entire surface of the plate. So you see that if you, at the end of the day, you are supposed to count the colonies. But if you have proteus that was spread throughout the entire plate, how are you going to do the counting? So you cannot do the counting. So the essence of the electrolyte deficient, you know, we have 16 lactose electrolyte deficient. The electrolyte deficient means that clade do not have electrolytes. When we talk about not having electrolyte, it means they don't have sodium, they don't have chloride. Okay, the sodium and then the chloride, they constitute the salt. So a lot of the media have some salt in it. The salt is to provide the electrolytes. The electrolytes facilitate the swarming phenomenon of the proteus. So it means that if the proteus want to swarm, they need electrolytes to do that swarming. Now, we want to count colonies. So if you want to count colonies, what must we do? We must prevent the proteus from swarming. So the essence of the clade, which is the 16 lactose electrolyte deficient, means that the absence of the electrolytes will prevent the proteus from what? Swarming, that's all. So in clade, proteus will not swarm. However, in a lot of other media, proteus will swarm. But in clade, proteus will not. So the essence of clade is to prevent proteus from swarming. And this thing is an easy question area. Okay, the essence of the electrolyte deficient in clade is to prevent proteus from swarming. That's all. Okay. Now, you must, sometimes you can also come across a medium called chrome agar. Chrome agar. The word chrome means color, isn't it? Word chrome is color, or chromatic, or chromogenic is color. Then agar. What it means, this is a new medium which has been developed, and it's usually used for urine cultures. And with the chrome agar, every organism will exhibit a unique color. So if it's E. coli, it will exhibit a unique color. If it's Klebsiella, it will exhibit a unique color. If it's Candida, it will exhibit a unique color, so that the colors are so unique that when you see the color, you see that it is this organism. And therefore, it is easier to use chrome agar. So elsewhere in developed countries, they don't use clade, they don't use McConkie or Brad agar for urine. They use chrome agar. So you must know that. Sometimes they will give you a series of media, they ask you which of the following is best used for urine cultures. Okay, then if chrome agar is there, please pick chrome agar, even though chrome agar is not all that common. In fact, it's not even available in our part of the world. But if you go out, the media used for urine cultures is chrome agar, not even clear. Just as we mentioned about heptoin enteric, if you go out there, they don't use SS agar or DCA, they use the heptoin enteric. So since you are being trained to be able to practice anywhere in the world, you don't say that, oh, you are going to ask the questions only about the things that is available in Konfonache or available in Kolebu. No. You are going to ask the questions about things that you are expected to know as a scientist. That is why some of these discussions are very important. Heptoin enteric is the media of choice for Asclepias Salmonella Shigella in cultures. Chrome agar is the media of choice for isolating pathogens from urine. Okay, right. Then we have thiamatine agar. I'm sure thiamatine agar, a lot of you have heard it before. We also have modified thiamatine, the same thing. Modified thiamatine agar or thiamatine agar. They are selective media for isolation of Neisseria. Okay, Neisseria, either Neisseria gonorrhea or Neisseria meningitis. they are better isolated from Martin agar. All right, so these are some basic things that I expected you to know. Then some other Lawrence Jensen medium, which we call LJ medium or LNJ, either LJ or LNJ, whichever it is, it's Lawrence Jensen. It is also the selective medium for isolation of Mycobacterium tuberculosis. Okay, in fact, the Mycobacterium species LNJ is useful, but remember that Mycobacterium leprae will not grow on artificial media. When I talk about artificial media, I'm talking about any of the media used in the labs. Mycobacterium leprae will not grow on media, artificial media. But any of the other Mycobacteria group will grow on media, and the media of choice is LNJ or Lawrence Jensen or LJ medium. So take note of that one too. That one too, irrespective of the level, they can act at any level. Okay. There is this one too. I'm just bringing up because I found it elsewhere. The perfect charcoal is extract agar. It's also a selective medium for Legionella pneumophilia. Legionella causes a lot of pneumonia in elsewhere. Okay. So, and then CIN2 is also specific for Yersinia. So this one, just take it, just in case you come across them. The perfect charcoal is extract agar is for Legionella. That's the selective medium for Legionella. And then the CIN agar, Cefazolin agarsin novobiacin agar is also the selective medium for Yersinia. This one, just take them just like that, and if you come across them anywhere, you can also pick up. And then we also have yes, I think these are the few media that I picked up. And so let's do some try questions quickly and then we go. The standard condition for efficient sterilization of culture media by not, so for any type of media, if you want to prepare, after preparing media, you have to sterilize it. There's a standard requirement for the autoclaving. And so let's quickly go through which will be the right answer. Yes, 121 degrees at 15 pounds for 5 minutes, 121 degrees at 15 pounds for 15 minutes, 121 degrees at 10 pounds for 25 minutes, 121 degrees at 15 pounds for 15 minutes. Yes, let's quickly go through this and then we call it a day.
The answer is B. The answer is B.
Come again.
The answer is B, 121 degrees Celsius at 15 pounds per 15 minutes.
Okay. All right. So this one is straightforward. And all of you should know this, especially the diploma level. Because some of such questions, they will not ask the MLS or MLSD people. But it is something that all of you should know. All right. Good. So Shamate, you want to talk? Hello. Shamate, I can't hear you properly. I gather that you want to talk. Shamate.
Yes, sir. No, I wanted to give the answer to the question which he rightly gave, the B.
Okay. So you're also for B. Okay. Thank you very much. Which one of the following is true? Agar has nutrient properties. Chocolate agar is a selective medium. Addition of selective substance in a solid medium, let me see, is called enrichment medium. Nutrient broth is basal medium. Yes, somebody to help us.
Hello, sir.
Yes, sir.
I will go for nutrient broth with basal medium.
All right, who else has a different answer? Who else has a different answer? And so that's correct. Nutrient broth is a basal medium. The rest are all not correct. McConkie agar is both selective and differential media. Which component of the media makes it inhibitory to the growth of gram-positive bacteria? Yes, this one I think we discussed it.
C, the bile salts.
Very good. The bile salts. Anybody with a different answer? Anybody with a different answer? So the bile salts. We said that McConkie is exclusively McConkie contains bile salts, and because of that, it allows the growth of the enterobacteria. Okay. Somebody, Abraham, can you unmute if you're not? Okay, thank you. All right. So the next, which of the following organisms, when grown in blood agar media, is classified according to its hemolytic properties? Yes.
Yes, sir.
Yes, sir.
Streptococcus.
Streptococcus, fantastic. Fantastic. That's correct. So it means that you are getting it. And these are sometimes some of the types of questions that they ask. When blood agar is slowly heated, it becomes, yes. When blood agar is slowly heated, it becomes
a chocolate agar.
Chocolate agar. Very good. That's all. Good. So we move on. The following are true of mannitol salt agar, except, yes, I'm sure you know about mannitol salt agar. So the following are true of mannitol salt agar, except. Yeah, somebody should try that for us.
A.
Except D.
When you say B, say A, for example, say A, say A for Albert, or A for Akosia. If you say D for, so that I can get it well. D for
okay, you said D for dog. D for dog.
Okay. Anybody with a different answer? Somebody said A. Anybody with a different answer? So you are having A and D. Anybody with different answers? All right. Hello.
C.
D for.
Say B for boy.
B for boy. Okay, so we have A, B, and D. So yes.
I said C for cat.
C for cat. Okay. So so we have A, C, and D. All right. So nobody likes B.
I said B. B for boy.
B for boy. So you have answer for A, answer for B, answer for C, answer for D. Hey, that become interesting. Though. So who support who? Yes. So all the answers are correct, because you are getting A, B, C, and D. Remember, they say the following are true of mannitol salt, except. So when you're reading, read well.
The answer is D.
The answer is D.
Okay, so I also go for the D. Okay, I also go for the D. Please don't make mistake. When you are reading, read to the end. When there's except, make sure you understand what they are talking about. Okay, good. The best medium for Mycobacterium tuberculosis is what? The best medium for culture of Mycobacterium tuberculosis. This one is bonus.
Is the L medium?
Is the C?
Is it C? Yes, C.
Yes, okay. So this one there, no problem. Then, which of the following media is used for routine isolation of Salmonella and Shigella from stool sample? Hey, this one there, you not even look at it. So that's good. So I'm happy about it. So please that you follow the discussion. Good. A medical laboratory intern on rotation in microbiology laboratory noticed that a culture broth. Listen to this, so it's very, you need to get some intelligence. A culture, I'm sure you know about a broth. What is a broth? What is a broth, please?
It's a liquid culture medium.
Very good. So the culture broth tube was very turbid at the surface, but clear throughout the rest of the tube. The intern can conclude that the A, organisms are aerobes. B, organisms should be grown in an anaerobic chamber. C, organisms cannot produce superoxide dismutase and or catalase. D, broth is sterile. Which is the answer?
A, the organism.
Very good, fantastic. Anybody with a different answer? Anybody with a different answer? So you see that if you have a broth, the upper part is exposed to, in the tube, the upper part is exposed to oxygen or to the air. So organisms which are aerobic will grow at the surface. Okay, and then as you're moving down, there is depletion of the oxygen. So down there, if the organisms are anaerobic, they will not grow there. Okay, but if the organisms, if there's cloudiness throughout the broth, what does it mean? If the organisms are, if the broth is turbid, remember if there's turbidity, it means that there's growth. Do you agree? In a broth, if there's turbidity, there's growth. Do you agree?
Yes, please.
So if there's turbidity throughout the entire broth, what does it mean? So if there's stability, that's not the question, but I'm just asking. If there's stability throughout the broth, what does it mean?
It means there is growth throughout the broth.
And so, how would you describe it?
The organisms are anaerobic. Anaerobes.
No, if they were anaerobes, they will not grow. If they were anaerobes, they will not grow at the surface. So it means they are facultative anaerobes.
Facultative anaerobes.
So those are sort of things that you must consider. All right. A lot of the time they ask questions, they want to test your knowledge, your science, and about that. So you just have to just be calm, think through scientifically, and the answers you'll always be able to suck out those that are not likely to be true. On that note, we bring today's session to a close. We continue next week. And remember, as we move up, we will do more of the in-depth ones. These are still basics, but they are good for both the diploma and all of us. As we move to next week, we get to more details, and I'm sure that you will enjoy the discussion, yes, both for preparing for exams and also for your own professional development. Thank you very much, and see you next week.
Thank you, sir.
Thank you, Grandpa.
And my guy should not forget to send me hi for his 10 cities data.
Okay, sir.
Okay.
Okay, sir. Don't worry, sir. We'll WhatsApp you together.
Thank you.
Who will WhatsApp you together?
Let's share it. Let's share it. Yes.
Okay.